Welcome everybody to the VacCAP webinar series. My name is Amaya Tucha and I'm a member of the VacCAP team and I will be today's moderator for this webinar. Today we'll be discussing willingness to pay for blueberries, sensory attributes, fruit quality traits, and consumer characteristics with Dr. Elizabeth Canales. Dr. Canales is an associate professor in the Department of Agricultural Economics at Mississippi State University. Her program focuses primarily on providing education and support to small businesses and specialty crop producers in Mississippi by developing training materials on farm management, understanding and using financial statements and operational information to improve business decisions, cost analysis, enterprise analysis, business development, and record keeping, among others. We're really excited to have Elizabeth today presenting some of the research that she has done for the VacCAP project. I will remind everybody to please, if you can stay muted and with your camera off. If you have any questions during the webinar, you can just put them in the Q&A and we'll read through those questions and Elizabeth will answer them at the end. And with that, we're gonna go ahead and start the webinar. Thank you.
Good morning, everyone, or good afternoon, depending on where you are. I'm going to share my screen. Can you see my screen well?
Yes.
Okay. So today, as Maya mentioned, I'm going to be talking about a paper on the willingness to pay for blueberry that was part of the VacCAP project and recently published in Horse Science. And I have included here the names of the co-authors in this study. So I'd like to start by talking about the growing significance of the blueberry industry and the importance of consumer preferences and from the industry to meet those preferences to further expand the blueberry market. So as many of you are aware of, over the past years, blueberries have emerged as an economically important crop, contributing about 5% of the total fruit production value in the US, which 5% seems low, except that when you compare all the fruits that are available in the market, 5% is quite significant. And so we've witnessed an important rise in consumer demand over the past years. So just to give you a sense of how quickly this market has grown, and you can see here in this graph that per capita consumption of blueberries surged from 0.26 pounds per person in 2000 to 2.77 pounds in 2020. So that's a 970% increase over 2 decades. If we were to look more recent over the last decade, that consumption or per capita consumption more than doubled during that period. So this massive jump represents opportunities for market expansion, especially considering that there was a study by the Packer in 2023 that found that only 37% of shoppers purchased blueberry during the past 12 months. So given that increase in demand and the fact that not everybody consumes blueberry, we can see there are some opportunities for expansion in this in the blueberry industry. So this rise in demand has led to a significant response from both domestic producers, which you can see here in green and in this graph, and also from imports, which is the orange side of those bars. And this is the result of increasing acreage around the world, the development of new cultivars, all of them to meet this increased demand. However, when focusing on domestic production here in the US, blueberry imports has actually outpaced that domestic production. So as you would expect, that leads to an increased competition and making the market more selective and quality driven. So all these shifts in the market raises an important question, which is how do we meet consumers' demand? How do we stay competitive in the market? And traditionally, breeding had previously focused on agronomic traits like yield and storage performance, but consumer preferences are a little bit more nuanced than that. So generally, when we think about what motivates consumers or what drives purchase decision, we think about flavor, texture, appearance, and fruit size. And those are things that tend to drive changes in the market as well. So again, it's very important to answer the question of how can we meet those consumer demands? How can producers, breeders, and marketers meet those evolving demands to stay competitive? And all of this really highlights the need to align breeding priorities and production practices with what consumers value in the market, with what motivates consumers to purchase and repeat those purchases in the market. So as we explore preferences for blueberries, I'd like to start by looking at some key findings and from previous research. Some things that you probably are familiar with, some studies that you're probably familiar with. So consumers are willing to pay more for larger blueberries. There are premiums associated with larger blueberries, and consumers sometimes associate that with higher quality. Some studies also have found that sweetness and sourness attributes are critical for consumer acceptance, and with the balance between sweetness and acidity being most preferred. Other findings also show that fructose drives overall liking of fresh blueberries, and also found the firmness is important as consumers like crisp textures. In terms of aroma's role, volatile compounds, which influence aroma, significantly impact consumer preferences and enjoyment of blueberries. And a study by Karina Gallardo with her co-authors also did a survey and found that many of the fruit quality traits demanded by consumers, such as flavor, aroma, and texture, so mostly quality attributes, also coincide with current breeding priorities in the blueberry industry. So our study aims to build on this by examining how sensory attributes and measurable quality traits translate into consumer willingness to pay. So in other words, how much into the relationship between the quality of those of the blueberries and how much or the price they're willing to pay in the market. And yes, I have a question there. Yes, all of this is blueberry related. So we're only focusing on blueberries for this presentation. So into this presentation, I will explore some of the factors influencing consumers' preferences and again, how they translate into market value. Specifically, I have the objectives here of our study, which is first, we want to examine how sensory attributes such as flavor, texture, and appearance liking, or flavor, sweetness, firmness, and juiciness intensity affect how much consumers are willing to pay for fresh blueberries. And the second objective, what we want to examine is how instrumental measures of fruit quality, so pH, soluble solids, sugars, acid content, firmness, corresponds to these preferences. And our idea here is we hope to help improve our understanding of the, sometimes complex relationship between or among sensory attributes, consumer preferences, willingness to pay, and those fruit attributes. So let's look at the details of our study and then we'll talk about the findings. So briefly discuss the materials and methods, and I don't want to spend a lot of time here. If you have additional questions, we can answer them at the end, but we're going to talk about the cultivars included in the study, the chemistry and texture analysis, consumer test, and then the willingness to pay elicitation. So just to give you an idea, we evaluated 52 blueberry cultivars, including 26 southern highbush, coming from Florida, University of Florida, Plant Science Research and Education Unit in Citra, Florida. And then we have 26 cultivars that were evaluated in Oregon, most of them predominantly northern highbush, except for overtime, I think. So about 3 kilograms of ripe fruit were harvested from each one of the cultivars a day prior to the sensory test. And then that fruit that was harvested was randomly sampled for the sensory analysis or for the instrumental chemical and texture analysis. So the samples for the sensory and the texture analysis were stored and analyzed within 24 hours of harvest. For the chemistry analysis, there were several indicators that were assessed. Using pure samples, the team evaluated or measured soluble solid content, pH, titratable acidity. Then samples for sugar and organic acids were frozen, and total sugars and organic acids were evaluated on freeze-dried blueberries using high-performance liquid chromatography. On the texture side, so 10 blueberries per cultivar were selected. They were diameter were measured, and they were weighted also. And the texture was assessed using a penetration method. So the values obtained for these different subsamples and replications of the fruit, we obtained the means for those, and those were used to relate those measurements to sensory liking, sensory intensity, as described by the panelists in the sensory analysis, and also relate those to willingness to pay. So a day after the harvest, we had a sensory analysis, and a total of 389 panelists participated across Florida and Oregon. So participants were recruited locally. Panelists in Florida mainly came from Gainesville, and in Oregon from Portland. Then each year, the sensory test was conducted over 4 separate sessions at each location. So instead of having panelists test multiple cultivars each time, we separated the sessions into 4, and during each session, the panelists evaluated up to 5 cultivars. So they were given 5 to 6 blueberries, served in a glass bowl, and then they were asked to evaluate the appearance, then to take 2 to 3 blueberries per sample, and then evaluate flavor, texture, and sourness, firmness, and juiciness. So for liking scores, so we asked how much they like the appearance, the flavor, and the texture using a 9-point hedonic scale. Then we also asked them to assess the intensity of sweetness, sourness, firmness, and juiciness using a 100-point scale. And then obviously these were presented in a balanced, random order using a balanced Williams design. So after the panelists tasted each one of the samples, or the cultivar samples, then we asked about how much they were willing to pay for the product, or for that sample of fresh blueberries. And here what we use is a double-banded dichotomous choice contingent valuation approach. And it's double-banded and dichotomous because we asked 2 questions. So after they taste the sample, we present a question to them, which is what you see here in the figure, and ask a yes or no question to whether they were willing to pay $3.29 for a sample, a 6-ounce clamshell of the sample they just tasted. Based on the response to the first question, and keep in mind, they always saw the first question, the same price, all of them. Then they were also asked a follow-up question, so whether they were willing to pay a higher price if they say yes to the first question, or a lower price if they say no to the first question. We had 10 price levels, and they were randomly shown to respondents. So at the end, what we have for each one of the panelists is 2 price bids, so 2 price levels for each one of the cultivars, and then we can estimate a willingness to pay regression, and we can use those sensory attributes of those product characteristics, blueberry characteristics, as explanatory variables to their question about their willingness to pay for the cultivars. So let's look at just what the data looks like. So at the bottom of this table, we can see the distribution of participants and cultivars tested each year. So you can see in Florida, we had a total of 90 panelists that tested 20 cultivars in 2021, and 95 evaluated 16 cultivars in 2022. In Oregon, we have 140 panelists that assessed 20 cultivars in 2021, and 100 evaluated 16 cultivars in 2022. So even though we have actually more panelists, we included the panelists that were able to attend each one of the sessions. So it means that they all tested all of the cultivars in our study. So just generally, I'm going to show here the characteristics of respondents. So we can see here, and I'm going to focus here on the pool sample. We see that 63% of the respondents were female. So this is not necessarily representative of the US population, but generally females are the ones who do most of the household purchases. So in that sense, that sample is acceptable. 50% of participants had an annual income greater than $50,000, which is a little bit lower than the 66% of the general population. And then in terms of age, we see the average age is 39 years. Again, it's very close to the median age of the US population, a little bit on the younger side when we consider that adults are the ones that do the majority of food purchases. When we compare Florida and Oregon, generally speaking, we see that the sample in Florida was a little bit on the younger side and with higher income when compared to participants in Oregon. So regarding the frequency of blueberry consumption, 61% of participants indicated that they consume blueberries weekly, with respondents in Oregon consuming blueberries more frequently than in Florida. So as we talked about the results, just keep those differences in mind. So on average, we see, let me see the laser here. So I'm gonna be focusing on the pool sample here when I'm talking about just generally summary statistics of sensory analysis. So generally, panelists liked the blueberries. 6.6 was the average overall liking. The mean for flavor was 6.55, and for appearance was 7.19, which is a little higher than the others. And just something to note here is that most of the fruit had good appearance. It had been recently harvested. So if we needed to analyze the effect of appearance, we will need more variability in appearance as we have as consumers to taste or to evaluate those blueberries. Generally higher sensory liking scores in Oregon compared to Florida. We also see the sourness intensity was the lowest with 40.98, which reported by panelists. We also see some lowering sourness intensity in other studies as well. And we also see that overall flavor was the highest intensity. And overall participants rated sweetness intensity lower than flavor. So they think the flavor intensity was higher than the sourness, than the sweetness intensity. And this is also the summary of instrumental measures. I'm not going to go over that. As you just this show you the variability in the attributes in the fruit tested across the locations and years. Okay, so for analysis, we first estimated Pearson correlation coefficients using individual participant sensories and mean instrumental values for each cultivar. So we'll discuss some insights from these correlations. So obviously, as I mentioned here, there are some limitations in that we are correlating individual participant data with mean instrumental values. So overall liking had the strongest correlation with flavor liking, so 0.91, followed by texture and appearance. So again, this strong flavor, overall liking with flavor liking is just consistent with previous studies that found that flavor plays the key role in consumer acceptance. When it comes to the relationship between the liking scores and intensity scores, we see that overall liking had the strongest correlation with sweetness intensity, 0.6, and very similar to flavor intensity of 0.59. Obviously, we see the negative correlation with sourness intensity, even though a little lower. The correlation between overall liking and firmness intensity was weaker, 0.33, compared to the correlation of overall liking with juiciness intensity. So here we also see, I'll discuss this later as well, but we see that juiciness do have an important role in the sensory acceptance of blueberries, and also willingness to pay. When it comes to texture and flavor hedonic likings, we also see a positive and strong correlation of 0.26. And similarly, overall flavor intensity was positive and strongly correlated with firmness, 0.50, and with juiciness intensity. Again, here highlighting the interaction between flavor and texture, those being correlated. Sweetness and sourness intensity scores were negative correlated, which could explain, the suppression effect of sweetness and sourness. I had an extra slide there. So the correlation coefficients among sensory scores and instrumental variables, as I'm gonna keep explaining on the next slides, were generally weak. For example, we can see here the correlation between pH and hedonic flavor and overall liking were almost close to zero. pH was positively correlated with sweetness intensity, 0.11, so still larger, but very weak. And negative correlated with sourness intensity and negative 0.32, so that was a stronger correlation between pH and sourness intensity. Overall liking was positively but weaker correlated with soluble solid content and soluble solid content to titratable acidity ratio. Then sweetness intensity had a stronger positive correlation with soluble solids than with the ratio. And then the sourness intensity had a stronger negative correlation with that ratio compared to soluble solids. So now looking at total sugars and total acids. Total sugars were positively and weakly correlated with flavor liking and overall liking. Overall flavor intensity as well, and sweetness intensity, so all positive, but still kind of weak. So the weak correlation between sweetness intensity and total sugar content could be explained by the added role of the organic acids also present in the fruits. And how sweetness and sourness mitigate each other. So we also found that the correlation between sweetness intensity and soluble solids was stronger compared to the correlation between sweetness intensity and total sugar content. Organic acids weakly and negatively correlated with flavor liking and overall liking. Again, what we think here is we're not able to necessarily capture the non-linear effect of acidity when it comes to consumer perceptions. And then organic content and sweetness intensity also negatively correlated, which has to do with the sweetness and the relationship between sweetness and sourness, and how the presence of sugar also mitigates the sense of how consumers perceive that sweetness in the fruit. Overall liking was statistically significant, but very negligible in terms of the size of the correlation with the mechanical measures of firmness, whether maximum force or Young's modules. And also we see that the correlation between overall liking and internal force was not statistically significant. So again, we also see in other studies that there is a weak correlation between those mechanical measures of firmness and subjective measures or sensory measures by consumers. So just key findings, just to summarize the correlation analyses. We see that overall liking had the strongest correlation with flavor. Overall liking had a stronger correlation when it comes to intensity with a flavor and sweetness intensity. overall liking was also positively correlated with soluble solids, total sugars, soluble solids to titratable acidity acid ratio. Negative correlated with organic acid content. Still, those measures were a little bit weaker when we compare when compared to those sensory values or sensory scores. So there are some limitations, obviously, to this correlation analysis, in that we're using mean values of the instrumental measures, whereas consumers taste different fruit and there may be some variability in the fruit that they're testing. So the mean may not actually reflect the variability in the sensory experiences that consumers are reporting. Also, our panelists were not trained panelists, which may be a difference with other studies where they use those correlations may be a little bit stronger because they're using trained panelists. And then again, the limitation with Pearson correlation, and that only measures or is able to capture linear relationships and not non-linearities in the relationship between the attributes and perceptions by consumers. So we then use regression analysis to examine the effect of the sensory analysis and the blueberry attributes on willingness to pay. So important to know that in this analysis, we're not focusing on the specific cultivars tested. We are rather interested in the characteristics of the blueberries and how they relate to consumers' perceptions. So the explanatory variables are going to be the characteristics of the cultivars and not the cultivars themselves. So we're going to follow an approach in the previous studies where we're going to be estimating 3 different types of models or 3 types of regressions. So in the first one, consumer preferences measured like liking scores and that 1 to 9 Likert scale are going to be used as the explanatory variable. So we want to see how much, when consumers say how much they like a fruit, how much that corresponds to the price they're willing to pay for that fruit. Then we are going to estimate a consumer intensity model. In this case, we're asking consumer how intense is the flavor, how intense is the sweetness or sourness of the fruit, and we want to see how that correlates to, again, how much they're willing to pay for that fruit. And thirdly, we're going to use an instrumental measurement model where we're going to include the attributes measured in the lab, so chemical and texture analysis measures, as explanatory variables in the willingness to pay, study. So in here we estimate different versions, and the idea will be to capture different measures of sweetness, acidity, and firmness. So the first regression is going to include pH, soluble solids, and mean internal force. In the second one, we're going to keep using mean internal force as the measure of firmness, but in the second one, we include titratable acidity and soluble solid content as the measures of sweetness and acidity. In the third one, we're just going to include the ratio of those 2 variables. And the third one included total sugars to total acid ratio. And the next, we're going to include total sugars, so nonlinear terms from total sugars, total organic acids, and the interaction between organic acids and total sugars. And the last 2 regressions is the same. We're going to be using the same measures for sweetness and acidity, but we're going to change the firmness measure to Young's module or maximum force, okay? So instead of showing tables with results, I'm going to present graphical results for key findings. So this graph summarizes the results of the consumer preference model. So these are liking scores. So we asked consumers how much they like the texture, flavor, and the appearance of the blueberries. And this is the effect of those liking scores on willingness to pay. So, so as we all expect, the more you like a fruit, the more you're willing to pay for it. As you can see in this graph, preference for flavor seems to be the most important predictor of willingness to pay. And we see that as the liking score increases by 1 unit, that is associated with 21 cents for each point, for an increase in each point in the Likert scale. So just to give you an idea of what that means is that if we take a blueberry with a mean liking score, which was 6.66, and the maximum liking score, that's a difference of 50 cents between a mean average fruit and a fruit that is liked the most in terms of flavor. Texture liking was the second best predictor of willingness to pay, with a 6 cents for each point increase. So again, so if we compare an average texture liking to the maximum liking, it's around 12 cents in difference for one small clamshell of blueberries. And less important was appearance, with 2 cents for each point difference in the liking scored. And again, as I mentioned before, we need to be careful with appearance because the fruit was generally fresh, and so there's no reason to expect that there were large differences in the appearance of the fruit in terms of freshness. Now, in this graph summarizes the results of the consumer intensity model. So remember, we asked consumers or participants to rate the sweetness, sourness, the intensity of sweetness, sourness, firmness, and juiciness of the blueberries that they tasted. So again, this graph shows that the perception of sweetness was by far the most important sensory attribute based on the magnitude of that effect. So we see a 1 cent increase associated with 1 unit change in the scale, which is a 100-point scale. So if we were to compare the fruit with the highest and lowest sweetness intensity, that's a difference of $1 between a fruit that's considered acid and a fruit that's considered sweet. The effect of sourness, intensity, and willingness to pay was also negative, but smaller in magnitude when we compare it to the effect of sweetness. Juiciness intensity, again, we found that the juiciness was more important in terms of the magnitude of the effect when we compare it to firmness. And that's something to explore further. As I mentioned, our panelists were not trained panelists. So the question will be whether they are able to accurately differentiate between what is a crisp, firm fruit and a fruit that's juicy. So something to explore, but for the most part, this analysis and the correlation analysis with the sensory liking both show that juiciness is very important and more important compared to what they perceive as firmness. In these and the next slides, I will summarize the results of the instrumental measurement model. And so to facilitate the interpretation of the regression results, we estimated the average predicted willingness to pay. So here in the y-axis, so this is the price. Think about the price for a small clamshell of fresh blueberries. So these are what consumers are willing to pay for the clamshell. And in the x-axis, we're going to have different levels of the attributes, in this case, different levels of pH. And then you also see in these graphs that we have some dotted vertical lines, and those are representing the quartile distribution of our values, or the values that we observe in our study for the cultivars included in our study. So as we can see here, the effect of pH was positive, but decreasing at higher levels of pH, as seen in this graph. Again, indicating that we need some acidity to enhance flavor. This figure also shows higher willingness to pay associated with pH values between 3.4 and 3.8, as you can see here, with the highest predicted willingness to pay observed for pH equal to 3.6. So this value is consistent with the 3 to a pH of 3 to 4 recommended as quality standard in the literature. This figure now shows the effect of soluble solid content on willingness to pay. This shows that participants' willingness to pay increases with higher levels of soluble solid content. However, we see the additional benefit of increasing soluble solid content decreases with higher levels of soluble solid content. So if you notice here, it almost reaches a plateau, right? Where the additional benefit of increasing soluble solid content between 15 and 16, there's really not a difference there. We see a higher increase for lower levels of soluble solid contents as opposed to reaching a plateau for higher levels of soluble solid content between 14 and 16. The effect of titratable acidity and willingness to pay generally showed a downward negative effect. However, the parameter for acidity was not statistically significant at any of the conventional levels. So now here I'm showing the results of soluble solid contents to titratable acidity ratio. So after exploring separately the effect of soluble solids and titratable acidity, we're looking here at the ratio of those two variables. So we found that willingness to pay increases as the ratio increases up to a ratio of 45, at which point we see that willingness to pay starts to decline. The highest willingness to pay was projected for a ratio of 45, although it's important to note here that we did not find a statistical significance difference between the willingness to pay projected at for a ratio of 35 and 45. So this value was somewhat higher than the quality standard of 15 to 30. It's sometimes recommended in the literature. So something to explore further in other studies. We also explored the effect of total sugars to total organic acid ratios, and again find a statistical significant non-linear effect. So similar to the soluble solid to titratable acidity ratio, we find that willingness to pay increases with higher ratios of total sugars to total organic acids, up to a ratio of 30. After that, we see a decline in the willingness to pay. So something also important to note here, that we did not find a statistical significance between 25 and 30 here, or 30 and 35. Also, if you notice the distribution of the ratios that we observe here, we see basically positive effect of that ratio for most of the observations in our data set. We had fewer observations with ratios larger than 16. So that's something to keep in mind as we think about how the precision with which we can estimate or forecast the willingness to pay for those ratios, because we had fewer observations with ratios larger than 16. In this graph now, we show the results of a model where non-linear terms of total sugars and total organic acids, as well as the interaction of those two, were included in the regression. So here we estimated the values of the projected effect of total organic acids, and then average over the observations of different values of total sugars. And I'm going to show what those values are at different levels of other sugars in the next slide. So we see here the average across observed values of total sugars. We show an increasing willingness to pay with increasing total organic acids up to about 80 milligrams per gram of dry weight. And then we see the willingness to pay starts to decline. And then here, an increasing benefit or a positive benefit of organic acid at the beginning for lower levels of organic acid content is just consistent with the need for some acidity to enhance flavor in fresh blueberries. Now, disaggregating the effect of total organic acid content for different levels of total sugars, we can see here that as we increase the levels of total sugar content, we see that willingness to pay increases up to about 140, 160 milligrams per gram of acidity. So at this point, what we observe is for 160 milligrams of total organic acid is that we see very similar predicted willingness to pay regardless of how much sugar content there is in the fruit. So what that means is that at higher levels of organic acid, the additional sugar content may not be enough to suppress the perception of sourness, which explain that higher levels of acidity here, we see very similar willingness to pay even when we increase the level of sugar content. Now, this graph shows the predicted willingness to pay across fruit size measured in millimeters. As you can see, size had a general positive effect. We did not find a statistical significance between the willingness to pay at 14 and 17. But then we saw that willingness to pay increases for fruit higher than 17 millimeters. And this is consistent with another study that showed around 17.7 as a new quality trait benchmark in blueberries. So again, what we observe is that consumers generally prefer larger fruit. Now, as I mentioned, we estimated 3 different regressions, and we included different measures of firmness. The first is the mean internal firmness, the second Young's module, and the third, maximum force, and the third is Young modules. So generally speaking, as you can see in this graph, we found higher willingness to pay associated with firmer fruit, whether measured by mean internal force, maximum force, or Young module. So when we look at mean internal firmness, we found optimal or highest willingness to pay for mean internal firmness of 0.5 Newton. For maximum force, we found higher willingness to pay around 2.4, but no difference between 2.4 and 2.6 in terms of the optimal willingness to pay. And then for Young's module, we found highest willingness to pay around 6, with no difference in willingness to pay for fruit with Young's module of 5 and 7. 7. Okay. Just to repeat here. So again, it's important to look at the distribution of the values. We did not have extremely firm fruit, but we do see that when the fruit is extremely firm, then consumers tend to not like that fruit. Across all regressions, we also see differences in how consumers perceive the fruit. Generally, we found that consumers that are frequent consumers of blueberries, so that means that they either consume blueberries daily or weekly, they generally tend to be willing to pay 7 to 12 cents more for a small clamshell of blueberries. So this is consistent with least frequent consumers being more price conscious. Age was also not linear, and we see here that elder consumers are willing to pay less. Generally, we thought of elder consumers as being more price conscious. Females were also willing to pay relatively more than males, but the difference was relatively small as well. Just to summarize what we found, when we look at preferences, like how much consumers like the product, what mattered most was flavor, how much they like flavor. That translated to higher willingness to pay. In terms of the intensity of what they perceived in the fruit, sweetness intensity was the most important, and it translated in higher willingness to pay. In terms of instrumental measures, we generally found some optimal values, and it's just something interesting to look into further. We found that titratable acidity to soluble solid content ratio between 35 and 45 was associated with the highest willingness to pay. A ratio of total sugars to total organic acids of 30, again, associated with higher willingness to pay. Total organic acid content, generally better, lower than 80 milligrams per gram of dry weight. And larger fruit, generally associated with higher willingness to pay for fruit greater than 17 millimeters. To finalize, I just wanted to show some general insights from the consumer survey. That was also completed during the sensory analysis and willingness to pay estimate test. And we see that 92% of respondents indicated that freshness was very or extremely important. 85% indicated that flavor was very or extremely important. Then ripeness, juiciness, sweetness, and firmness were also important. So these are some of the variables that we don't specifically tested in the study that is also important to analyze in the future. For example, freshness was very consistently indicated as one of the main issues or one of the main factors seen or evaluated by consumers in other studies as well that we conducted as part of the VacCAP project. Now, not all the participants in our study consumers blueberries frequently. So we asked these consumers, what were the main barriers for them not consuming frequently? And 36% of them indicated that price was the main factor. 25% indicated that short shelf life was the most important factor. And again, these are very consistent with results that we also conducted with a team here for VacCAP, where we find that price, so economic factors, as well as shelf life, are some of those main factors that are limitations to expand the consumption of blueberries. So with that, I'll take any questions you may have at this point.
Great, thank you, Elizabeth. I don't know if anybody have any questions. I don't see any specific questions in the chat, but since we are sort of a small group, I think it's fine if people want to unmute and just ask directly a question. Or you can still, type it on the chat. I'm happy to read it.
Hi, Elizabeth. Thank you very much for the great presentation. Calling in from British Columbia here. I might have missed it on the materials and methods slide, but could you detail a little bit the difference in the methodology used for measuring TA versus organic acids?
Yes, so that's not my area necessarily. So let me, so TA was, okay, I'll have to.
I think I can probably answer that, but I would assume that it's the pH and the TA. The TA was probably used with a titrator, and the pH with just a pH meter.
Yes.
And sorry, I asked about the organic acids though.
HPLC.
Mm-hmm. Yeah, HPLC.
Yeah, that's correct.
Yeah. So yeah, Massimo probably knows more about that since he was in charge of all of the chemical and textural analyses.
Great, thank you.
So we have a couple of questions here in the chat. The first one says, any ideas what factors drive perception of freshness?
Yeah, so that's something very interesting in that this was not part of the main study, so we actually did not test freshness, and that's something that we want to study in the next round of VacCAP, because it came up in some of the additional surveys questions that we included in our study, but we did not test for freshness, and that's something that we want to explore. So freshness and shelf life came up as one either most important factor of a barrier, where barrier will be shelf life. But yeah,
I wonder whether it could be
tested.
Maybe appearance, but you said that they all look pretty fresh.
Yeah.
So that might be something, or the juiciness might also be something, but that's interesting to follow up on that.
Yes,
We have another.
Oh, sorry, we did not have enough variability in the appearance of maturity of the fruit to be able to test it. So that's something we need to do.
Next question from Jordan says, do we have data on how the cultivars perform on the hedonic scale compared to each other?
Yes, we do. And it's something that I'll be happy to share. I just did not include it in the paper or in this slide, but we did have the graph that shows the differences in willingness to pay for the different cultivars each year.
Right. Then we have another question on any data about demographics of the panelists.
Yes, and I showed there's we had age, income, gender. And I think we had other additional demographic variables that we did not include in the study, but we did include control for differences in age, gender, and income.
And Elizabeth, do you have a link to the paper to see if some of the attendees might be interested in?
Yes, let me post it. Yeah, let me post it here.
I don't know if in the meantime we have any other questions for Elizabeth.
Yeah, so that's the link to the paper.
Perfect. I'm gonna leave a couple more minutes if somebody has another question that they want to ask. In the meantime, Josie, you want to share your screen, and we have we're going to advertise our next webinar if you're interested, and you can share the information with folks that might be interested. We will have our next webinar in November. I think it's October, Friday, October 25th. We will have Dr. Charlie Lee will be presenting on high throughput assessment of blueberry fruit internal bruising using deep learning models. So you can register. We will have we will share, or we will, if you are not part of our VacCAP list, you can probably sign up on our website, and we will be sending an announcement to register for this webinar coming up on October 25th. Well, it looks like we don't have any other questions. And again, if somebody has a question and they want to unmute, you can just go ahead and unmute if you want to, and just ask the question directly to Elizabeth. Okay, well, it seems like there's no more questions. Elizabeth, thank you so much for presenting today. And thank you everybody for attending. There will be a follow-up webinar, a follow-up survey to this webinar, and we will really, really appreciate if you take the time to answer. It's going to be short, and it really helps us support these webinars and get some feedback on the work that we're doing. Thank you so much for attending.
Thank you, everybody.